All right, so hopefully this will help if you're struggling with the different variables that we're dealing with the time dilation and the length contraction. And we have delta t, we have delta tau, and then v and c. So v and c, they're easy ones. V is the relative velocity between two frames of reference, or how fast you're perceiving the object to be moving if you are standing still. And then c is the speed of light. But the tricky ones, what do you assign to delta t and delta tau? And so delta t is going to be the time that's measured in a frame of reference away from the moving object. So that's going to be your object at rest, observing the moving object. What do they see? And then the delta tau is the time measured in the same frame of reference as the moving object. And so when you finish up a problem with this, you want to double check your answer to make sure you put the t and the tau in the right place. And so just kind of keep in mind that the faster a clock is moving, the slower it appears to run from a frame of reference that's at rest with respect to the clock. You go back to the clock problem and think of it that way. That might help you out. And then length contraction, kind of a similar issue. We talked about the V and C are going to still be the same idea, but L is the measured length of the object in motion. And L naught is the measured length of the object at rest. What does it look like sitting still? What does it look like in motion? Both of these are going to be from a standing still frame of reference. And, kind of double check what's going on. The faster something's moving, the shorter or smaller the object is going to get. All right, hope this helps. Bye-bye.